Good afternoon, everyone. Welcome in Elementary Statistic and Probability. We are the Group 3 in Tanawan Institute and we have the mission and vision. Our objectives are explain the role of sampling in the research process, distinguish between probability and non-probability sampling, understand the factors to consider when determining sample size. Understand the step in developing a sample plan. The goals of sampling are to use a procedure that is likely to yield a representative sample of the population as a whole, because our topic is the method of drawing a random sample.
Of sample and statistical inference. Statistical inference is a method of making decisions about the parameters of a population based on random sampling. And the branches of statistics which is concerned with using probability concept, it refers to the process of selecting and using a sample to draw inference about population from which sample drawn. Components used for making statistical inference. First, sample size is the act of choosing the number of observation or replicate to include in a statistical sample. Next is the variability in the sample. It is the range of values differs between sample, and the last is size of the observed differences. Sampling, the process of selecting a number of individuals for a study such a way that the individuals represent the larger group from which they were selected. Sample, study a population in the target population. A sample is a smaller but hopefully representative collection of units from a population used to determine truths about the population. Field 2005. The sampling frame, a list of all elements or other units containing the elements in a population. Population, the larger group from individuals are selected to participate in a study. Target population is a set of elements larger than or different from the population sampled into which the researcher would like to generalize study findings, and defines those units for which the findings of the survey are meant to generalize. To generalize the theoretical population. What population can you get access to? The study population. How can you get access to them? Using the sampling frame. Who is in the study? The sample. Purpose of sampling, to gather data about the population in order to make an inference that can be generalized to the population. Stages in the selection of a sample. First, define the target population. Next, select a sampling frame. Next, determine if a probability or non-probability sampling method will be chosen. Plan procedure for selecting sampling units. Determine sample size. Select actual sampling units. And last is conduct field work. Quantitative sampling. Purpose: to identify participants from whom to seek some information. A population does not have a specificable probability of being selected. Issues: nature of the sample, random samples, size of the samples, and the method of selecting the sample. Quantitative sampling, important issues. Representation: the extent to which the sample is representative of the population. Generalization: the extent to which the results of the study can be reasonably extended from the sample to the population. And the sampling error is the chance occurrence that a randomly selected sample is not representative of the population due to errors inherent in the sampling technique. Aspect of the researcher's sampling design creates bias in the data. Three fundamental steps. First, identify a population. Next, define the sample size. And the last is select the sample. Sampling in quantitative researchers is probability sample and non-probability samples. Have probability sampling methods and non-probability sampling methods. In probability sampling methods, we have simple random sampling, cluster sampling, systematic sampling, and stratified random sampling. And sa non-probability sampling methods, we have convenience sampling, judgmental or purposive sampling, snowball sampling, and quota sampling. Sampling techniques. Probability sampling is based on the fact that every member of a population has known and equal chance of being selected. It uses random sampling technique to choose a sample. It must be selected using a random selection. Probability sampling is a sampling technique where the odds of any member being selected for a sample cannot be calculated. It's the opposite of probability sampling. In addition, this type of sampling techniques relies on the subjective judgment of the researcher. As a sampling technique in which the researchers select samples based on the subjective judgment of the researchers rather than random selection. Probability sampling. Simple random sampling. Simple random sampling is characterized by the idea that the chance of selection is the same for every member of the population. This is the most frequently used type of probability sampling technique. Subset of individuals chosen from a larger set in which each individual is chosen randomly. Sampling. In this sampling technique, a random sampling is made of the first element for the sample. Then a subsequent elements are selected using a fixed or systematic interval until the desired sample size is reached. Is the method of involving the selection of elements from an ordered sampling frame. Stratified random sampling. In this sampling technique, a target population is first separated into mutually exclusive, homogeneous segments or strata, and then simple random sample is selected from each segment stratum. The population of junior high school students in Mabuhay National High School is 1,200. Use this population to make stratified random sampling. Grade levels. Grade 7, 350 population. Grade 8 is 300. Grade 9 is 380. And grade 10 is 270 with a total of 1,200. Sample is equals to 5%. Sample equals population over 1 plus population e squared is equals to 1,200 over 1 plus 1,200 opening close parentheses and 0.05 square root equals 1,200 over 1 plus 3 is equals to 1,200 over 4 is equals 300, and the 5% of 300 is 0.05. Next is the population of junior high school students in Mabuhay National High School is 1,200. Use this population to make stratified random sampling. 1,200 times 300 equals 87.5. 1,200 times 300 equals 75. 1,200 times 300 equals 95. 1,000 times 300 equals 67.5. Kaya hindi ni-round off yung 67.5 kasi mas mataas yung 87.5 and equals to 88 and the sum is 300. Probability sampling. Convenience sampling. Under this sampling, the sample elements are selected from the population based on their availability on the convenience of the researcher. The purposive sampling. Under this sampling, the sample elements are selected from the target population on the basis of their fit and the purposes of the study and specific criteria. Sampling, it means to take a very tailored sample that's in proportion to some characteristic or trait of a population. Snowball sampling. Under this sampling, the researcher identifies a key informant about a research interest and then asks the respondent to refer or identify another respondent who can participate in the study.
Randomization techniques. Flowchart for selecting appropriate randomization techniques. The gray boxes represent appropriate techniques. What is the sample size? small to moderate, n less than equal to 100. Large n greater than 200. Simple randomization. Are there covariates that need to be controlled? Yes, no. No is the black mode randomization. Are the participants enrolled in the study continuously or all at the same time? Continuous same time. Same time is stratified randomization. Covariates adaptive randomization. Simple randomization. Imbalance of sample size between treatment arms due to sample randomization. Coin toss in a small trial. N equals to 10, open close parenthesis. White is a control. Black is a treatment. Black randomization. Black randomization procedure produce balanced study arm even with a small sample size. Black randomization. A. Black size. B. Possible balance combination 2 2 control groups. 2 treatment groups. C. Random selection of blacks. 1 3 4 4 3 6 1 2 5 2. Assignment of all 40 participants. Stratified randomization. Procedure produce equal size study groups that are balanced by covariates. 2 covariates. Sex, 2 levels, male and female. Body mass index, 3 levels, underweight, normal, overweight. 8 is random assignment of male and normal. Simple randomization by flipping a coin. Covariate adaptive randomization. Breakdown of the first 9 participant groups assignments by covariates, sex and body mass index. Control group, treatment group. Covariate adaptive randomization. Taves and Pocock and Simon covariate adaptive randomization procedures. The 10th participant is male and belong to the underweight group. Male and underweight categories and marginal total of initial 9 participants are shaded. Taves method 1974. A added marginal total in control group equals to 3. 2 per male category plus 1 per underweight category. Add marginal total in control group equals to 5. 3 for male category plus 2 for underweight category. B. Assign the 10th participant to the lower marginal total, which is control group. 5 less than 3 less than 5. Pocock and Simon method 1975. A. Marginal total in control group equals 3 for male category and 2 for underweight category. B. Male category 3 minus 3 equals to 0. Underweight category 2 minus 2 equals to 0. Sum of the difference equals to 0. Plus 0 equals to 0. C. Marginal in treatment group equals to 0 for male category and 3 for underweight category. D. Male category 2 minus 4 equals to 2 underweight category. 1 minus 3 equals to 2. Sum of the difference 2 plus 2 equals to 4. E. Assign the 10th participant to control group, etc. 0 is less than to 4. The table of random numbers. How to use a random number table. Note, this method is one from a variety of methods of reading numbers from random numbers tables. Number 1. Assume you have the test score for a population of 200 students. Each student has been assigned a number from 1 to 200. We want to randomly sample only 5 of the students for this demo. Number 2. Since the population size is 3-digit number, we will use the first 3 digits of the numbers listed in the table. 3. Without looking point to a starting spot in a table, assume we land on 75636, third column, second entry. 4. This location gives the first 3 digits to be 756. This choice is too large, greater than 200. So we choose the next number in that column. Keep in mind that we are looking for numbers. Choose first 3 digits are from 001 to 200, representing students. 5. The second choice gives the first 3 digits to be 407, also too large. Continue down the column until you find 5 of the numbers whose first 3 digits are less than equal to 200. 6. From this table, we arrive at 070 or 07015, 38, 038 or 03811, 045 or 04595, 055 or 05542, and 149 or 19428. 7. Result student 38, 45, 55, 70, and 194 will be used for our random sample. How to use random numbers generator. Calculator use. Generate one or more random numbers or random letters set from a range of numbers or letters. The random numbers or letters will be random sample set. For sample size, enter the value for the numbers of samples you need. For the samples range, enter the range of values to randomly choose from for example, to choose from 1 to 100, entry 1 to 100, to choose from the true M, enter AM or AM. If the sample size is greater than the sample range and duplicates are not allowed, the numbers of result will be limited by the range. Generate a random number for a pin. To generate a 4-digit pin without duplicate digits, choose sample size. For sample range 0 to 9 and allow duplicates no. Example, 4-digit pins without duplicates. To generate a 4-digit pins with duplicate digits, choose sample size for sample range 0 to 9 and allow duplicates. Yes, this will allow duplicate but will not necessarily produce duplicates every time. If you actually want duplicate, you may need to try several times. Example, 4-digit pins with duplicates. Numbers and letters set generator. Create offset of samples. Sample size 5. Sample range 1 to 100. Allow duplicate? No. Print commas? No. And then calculate. The answer is 9, 38, 16, 45, and 82.
Probability sampling techniques. We have the SRSWOR or simple random sample without replacement, and SRSWR or simple random sample with replacement, cluster sample, and stratified sample according to age. Simple random sample without replacement or SRSWOR of size. This is created by drawing of the n tuples from D to S less than n, where the probability of drawing any tuple in D is 1 over n, that is, all tuples are equally likely to be sampled. Simple random sample with replacement or SRSWR of size. This is similar to SRSWOR except that each time a tuple is drawn from D, it is recorded and then replaced. That is, after a tuple is drawn, it is placed back in D so that it may be drawn again. Cluster sample. If the tuples in D are grouped into M mutually disjoint cluster, then an SRS of S cluster can be obtained where S less than M. For example, tuples in a database are usually retrieved a page at a time, so that each page can be considered a cluster. A reduced data representation can be obtained by applying, say, SRSWOR to the pages, resulting in a cluster sample of the tuples. Other clustering criteria conveying rich semantics can also be explored. For example, in a spatial database, we may choose to define cluster geographically based on how closely different areas are located. Stratified sample. If D is divided into mutually disjoint parts called strata, a stratified sample of D is generated by obtaining an SRS at each stratum. This helps ensure a representative sample, especially when the data are skewed. For example, a stratified sample may be obtained from customer data where a stratum is created for each customer age group. In this way, the age group having the smallest number for customer will be sure to be represented. The formula for possible sample with replacement. There are many different combinations of objects that could be selected while drawing a sample from a population of them. Number of possible sample with replacement is equal to total units to number of selected units. Number of possible sample with replacement or capital N to smallest n, where capital N is equal to the number of total population and smallest n is equal to number of units to be selected. The formula for possible samples without replacement is most commonly used sampling. Subjects are typically not included in the sample more than once without replacement. Total number of units factorial over the number of selected units factorial times difference in total units and selected units factorial. Number of possible samples without replacement is equal to the population factorial over the sample factorial times the population minus the sample factorial, where capital N is equal to the number of people in the population and small n is equal to number of a person to be sampled, and sa factorial it is the factorial notation. Sample problem number 1. Let's assume there is a total of 9 players, out of which 3 to be selected to be taken on the playing team, and the selector decided to use the sample method by replacement. In that case, there are a number of combinations in which players could be selected. The N, capital N to smallest n is equal to 9 cube is equal to 729. In other words, there are 729 different combinations of 3 players that could be selected. 2. Let's take the same example, but this time without replacement. In that case, the number of combinations in which players could be selected, 9 factorial over 3 factorial times 9 minus 3 factorial. 9 factorial over 3 factorial times 6 factorial. It equals to 9 times 8 times 7 times 6 factorial over 3 factorial and 6 factorial is equal to 9 times 8 times 7 over 3 factorial is equal to 84. In simple words, there are 84 ways to select the combination of 3 players in case of sampling without replacement. Sample problem number 3 with Excel templates. If a cinema hall wants to distribute 100 free tickets to its regular customers, the cinema hall has a list of 1,000 number of regular customers in his system. Now, the cinema hall can choose 100 customers randomly from its system and can send the tickets to them. Solution: use the given data for the calculation of simple sample sampling. We have the particular and values. The total population is equivalent to 1,000 and sample is equivalent to 100. Calculation of probability can be done as follows. Probability is equal to number in the sample selected over total number of population is equal to B4 divide B3 is equal to 1,000 divide 100. Probability will divide is equal to 10%. Sample problem number 4. ABC Ltd is the manufacturing company engaged in the manufacturing of bulbs. It manufactured 10 bulbs in a day. It comprises of quality inspection team, which is tasked with surprise inspection of bulbs and for measuring the overall feasibility of the company to manufacture good bulbs. They decided to inspect the bulbs on a random basis, and they decided to take a sample of 3 bulbs, and it was provided that on that particular day there were 2 defective bulbs and 8 good bulbs. Compare the result in both cases of sampling with replacement and without replacement. Solution. Use the given data for the calculation of simple random sampling. We have the total number of population, 10 with replacement and 10 without replacement. Number of good bulbs, 8 with replacement and 8 without replacement. Number of defective bulbs with replacement is 2 and without replacement is 2. In case of sampling with replacement, number of sample that could be selected equals to total units to number of selected units of the sample is equal to 3 cube is equal to 1,000. That means there are 1,000 possible samples that could be selected. Let's denote the population like this: G1, G2, G3, G4, G5, G6, G7, G8, D1, D2. Then the sample could be G1, G2, G3, and G1, D1, G7, and so on, totaling to 1,000 samples. Now, let's say what will be probability that the sample selected by the invigilator will have at least one of the defective bulbs. In case of sampling with replacement, probability at least one defective equals total probability minus probability non-defective, where total probability means the probability of the total population universal set always 1. Calculation of probability of selecting good bulbs. Particular and with replacement. Total number of population is 10. The number of good bulbs is 8. Number of defective bulbs is 2. Probability of selecting good bulbs. In first row, we have 0.800 is equal to B over B3. In second row, we have 0.800 is equal to B4 over B3. And third row is 0.800 is equal to B divides B3. Probability non-defective is equal to probability goods times probability goods times probability goods. We have first row, second row, and third row is equal to n number of good bulbs divides the population of total number of bulbs times a sample number of good bulbs times population total number of bulbs times sample number of total of good bulbs and population total number of bulbs. Using probability formula with replacement is equal to B7 times B8 times B9. Probability of selecting all good bulbs in all rows is equal to 8 divide 10 times 8 divide 10 times 8 divide 10. The probability of selecting all good bulbs in all row is equal to 0.512. Now, putting these values in the main equation, we will get probability at least one defective is equal to total probability minus probability non-defective is equal to 1 minus B10 is equal to 0.488. Probability at least one defective is equal to total probability minus probability non-defective is equal to 1 minus 0.512 is equal to 0.488. The explanation, the probability of selecting good bulbs always came 8 divide 10 because after each draw, the selected bulb was replaced in the total group, thus always making the total number of good bulbs in the group 8 and the total size of the group having 10 bulbs in total.